Welcome to the tutorial of Laboratory 5 for IE 574. So in this tutorial we're going to talk about two main things. The first one being how to rotate the tip of this robot. We've already learned how to move it, but not how to rotate the tip. And the second thing that we're going to talk about is about a blob tracking camera. Alright? So this blob detection camera has a lot of functionality, but we're going to only be using its raw image so you guys can implement the algorithms and the formulas that we gave in class. So let's first talk about the robots. And I wanted to clarify, just in case, this is the same case as in Laboratory 5, but I wanted to clarify just in case. So what I wanted to talk about first is how this different robots handle the objects in the hierarchy. So if you look at the code from these three robots, you'll notice that it's the same code for three of them. So if I go, for example, if I compare this code of the IRB 360 to the IRB 360, and you see the object handles that I'm getting, so I'm getting the object handle for the target drop and the suction pad, and in here I'm getting the same object handle. This doesn't mean that both robots will be getting the handle, in the case of a target drop, of this target drop. When we're using, when we're querying the, when we're trying to get the object handles in VREP, since this robot has a hashtag or number 0 in here, this means that if I try to get a target drop, it won't look for target drop. It will look for target drop number 0. So it will actually look for this element in here. And if I go to the IRB 360 number 1 and go to this sim get object handle, this target drop won't be again the target drop in here, but it will be the target drop number 1, because here it has a number 1 too. All right, just to clarify that. All right, now let's get to the actual business of rotating the tip of our robot. So this time, instead of providing you, we made a few changes to the move to target function. So if I go to the robot here in the middle and I open it, so you remember that for this script, we actually run a threaded function over here, and this is a function that would execute, because we're calling it down here, and in a while this while is the thing that will actually execute all the time. So you see this is a move to target function. It's almost the same. This actually moves the robot to the target that you specify, but it also has a new parameter, the rotation. So we made this so the rotation would be in degrees. And what this means is, this means if I put 0, I don't want the tip of the robot to rotate at all. But if, for example, I added a second element, so this will move the robot to the drop target, and it won't rotate the tip at all. If after I go there, I want to rotate, for example, I would still make it move to drop. I will make it steady in drop. But for example, I'm going to make it rotate a half a circle. All right, so that would mean I would rotate it 180 degrees. And since this repeats all over and over again, what the robot would do is actually go to a drop position, rotate 180 degrees, and then rotate to its original position. Rotate to 180 degrees, and then rotate to its original position, and loop this forever. So if we hit play, and I'm going to actually select the suction pad so you can appreciate how it's moving. If I hit play, the robot will move, and then it'll rotate 180 degrees and then go back, right? 180 degrees. It's very easy to appreciate that it's moving half of a circle. All right, so this is how you twist this joint over here, and it's very, very easy. And now that we're done with this, I'm actually going to talk about the blob detection camera. So I'm going to play it for a second, and I want you guys to pay attention to this window that we have in here. So this is an image, and I'm going to talk about a little bit of how images are represented. Okay, so this is a blob tracking camera, and it's tracking the blobs, but when you go to the code, you won't be able to access any of this information because we want you to do it, to implement these things by yourself. So what I wanted to do here is tell you a little bit about how images are usually represented. So if this is an image, and in this case, this image has a width of 256 and a height of 256. This means that the width is of 256 pixels, and so is the height. So usually, when we get the data of an image, what we would get is a matrix. In this case, it would be a matrix of 256 rows and then 256 columns. So the rows are, the number of rows is determined by the height of the picture, and the number of columns in the matrix is determined by the width of the picture. Right, so if the image is represented as a matrix, each element in the matrix would represent a pixel. So if I, for example, wanted to know what is the value of the pixel that is in the position 0, 0, I would get the element 0, 0 in the matrix. So I'm going to stop the simulation a little bit and explain how the images are actually represented in VRIP. So if I have a little bit of an example in here. So imagine this is an image of 3 pixels wide and 3 pixels of height, all right? So in total, we would have an image that has 9 pixels. This is a grayscale image, and the range of this grayscale image is from 0 to 255. 255 representing pure white and 0 representing pure black. As you can see, there's numbers in the middle that kind of go gray. So as you can see, numbers that are closer to 0 will be darker, and numbers that are closer to 255 would be lighter, right? So if this was an image, and the usual way of representing would be a 3 by 3 matrix, and if, for example, I wanted the value of the pixel that is in the position x3, x1 and y3, which it would be this pixel, I would get the element of the matrix that it's in row 1, column 3. All right? This is how you usually represent. So the values of the pixels directly go mapped to the values of the elements in the matrix. All right, so the thing with VREP is that instead of having this matrix representation of an image, we have the elements in a table that it's just for practical, for practicity, we're just going to call it an array. So instead of being like a matrix, it's a linear array like this. The thing is that this linear representation might be uncomfortable sometimes if I want to detect a shape, because if I want to detect a shape, for example, imagine that I want to detect that if these 4 pixels are all black and they're part of some shape that I'm detecting. So imagine I'm trying that my image looks something like this. Don't pay attention to the numbers, right? Because it should be like 255 all over here, and this one should be, all the pixel values should be 0. So I'm going to fill this with black. All right, so all these values should be now be 255. I'm going to put them just in case so you don't get confused. Oh. I'm going to cut and edit it, so I'll get back to you when it's ready. Okay, so we're back. Imagine that this is a part of our camera and we're trying to detect an L shape, for example. And in this matrix is very, very easy. So imagine the conveyor belt will be, this case we only have pure black and pure white. We already did, for example, some thresholding to make the image like that. And imagine the black part is the background and the white part is the figure that we're trying to get. So if I look at the picture of the image like this, it's really easy to think about the shape of the image because in here I can clearly see an L shape going on. But if my image is represented linearly, as it is in VREP, it might not be as intuitive. If I go here, it might not be as intuitive that this has an L shape. That is why we made two functions for you that I'm going to explain. So even though you have your your array like this, even if your image is represented like this, we gave you two functions so you're able to query these pixels to get these pixels as if you had the matrix instead of the array. So instead of trying, if for example, if I wanted the element in the, for example, if I wanted the element that it's in the second row and second column, instead of calling, instead of trying, instead of making you guys just go to the element 1, 2, 3, 4, 5, 6, we actually we're giving you a function so you can query like give me the pixel that is in position 2, 2, and it actually go over this array and give you the position that would correspond to the position of this element if it were in a matrix. You don't have to use this at all, this get pixel function that we give to you, but if you feel more comfortable thinking about your image as a matrix, you can do this. All right, so let's get back to the code. I'm going to quit this. It's not necessary anymore. Right. All right. Let's get to the blob detection camera. And here is the element, the code. So if we go here, this, I'm going to remember you, this is a non-threaded script, so this will execute on every cycle of VREP. So in here, what we have is the initialization code, and it finishes here. No, it finishes here. So this will execute only once, the first time. And in here, you actually have the code that will execute with every call. All right. So I'm going to tell you a little bit about the parameters that you'll get when you have initialized your script. So this is getting the handle of the camera. And the element that interests us in here is this res element in here. So this resolution element that we have in here has two elements. One is the width. This is an array of two elements. One has the width and one has the height. So this resolution variable has is an array of two elements. The first one would be the width, and the second one would be the height of the picture. For this case, it would be 256 by 256, just in case you wanted to know. All right, so if I wanted to access, for example, the width of the image, I would do resolution. So res, and I would access the first element. And if I wanted to access the height of this image, I would do just res2, and this would give me the height of the image. All right, so now that we're in here, I'm going to talk um, about the get pixel and set pixel functions that we have over here. All right. So basically what this is doing is what we talked about. If you don't want to handle the image as a linear array, we provided with this function get pixel and set pixel so you guys could handle this image as if it were a matrix. So basically what we're doing is I'm giving you what you have to do to get the pixel value of an image as if it were a matrix is that you give as the parameters as you give the image, you give the position x, the position y would be corresponding of the row number and the column number of the pixel that you want to get, and then the max y. This can be max x or max y because the image is squared, so it doesn't matter. So I just put one of them in here. It doesn't matter. It could be any of them. If the image was not the same size, this would have to be the maximum number of columns. So it would have to be the max y, but it's not important for this case. All right, so this would not only give you the image, let you treat the image as if it were a matrix, but this would also let you treat the image values as if they were from 0 to 255. So when we get the image from VREP, our pixels don't have a range of 0 to 255, 0 being black and 255 being white. Our pixels are in a range of 0 to 1. So now this is up to you. If you want to handle your image as a matrix, but you actually want to handle the value, the range value of the pixels as it comes in VREP, so from 0 to 1 instead of from 0 to 255, the only thing that you have to do is in both get pixel and set pixel, uh, delete the multiplication by 255 and the division by 255. So this is just in case you want to handle the range of the matrix being for the range of the pixel being from 0 to 255. Okay, so this lets you get the pixel, and this in here will lets you set the pixel. All right, so what this is doing, this also receives an image. This receives the position x and y of the image of the pixel that you want to change, and this, all right, this is again the max number of columns that this image has, which in this case would be the width, and the value that you want to set that pixel to. So this is expecting a value between 0 and 255, and what we're doing here is we're dividing it by 255, so it gets stored in a value of 0 to 1. So as you can see, this get pixel and set pixel will let you work with the image as if it had a range of 0 from 255, but if you actually look at the pixel through the array instead of through these functions, you'll get the value that you'll notice that the value is actually from 0 to 1. So all of the values are being stored in the range of 0 to 1, all the pixel values, but if you use this function, they'll be translated to you to the 0 to 255 scale. All right, this is a copy function that I'm going to talk about a little later, so we're not going to address it now. And now we get to the part that executes all the time. So the things that interest us in here is the image analysis frequency and then how we actually get the image. So let's get first to the image analysis frequency. This, what it's doing, it's determining how often do you pick up an image. So let's check how it is now. If I hit play, you'll see that it's not so often this happens, because you can actually see when you get the pieces, you'll see them skipping a little bit, so it's not that continuous. So you see little jumps because it's not checking it all the time. If I wanted my camera to check more frequently, what I would have to do is in the block detection camera, you have the script and then you have this symbol over here. This is the parameters of this script. So if I double click it, I'll get the image analysis frequency and I can change it to here. If I change it to 10, for example, this will pick the images in a more frequent fashion. So I don't know if you can see it with the resolution, but already you can see the conveyor moving so much more naturally. And as you can see, you see the object almost flowing as you see it in the image in here. So this is if you give it a higher rate, it'll pick up the image more frequently. So why would you like to play with this? For example, if your algorithm is taking too much or your formulas are taking too long to calculate, you could reduce the speed of the conveyor belt and then reduce the frequency for which you pick the image. For example, you could make it less than 1, and then this would give the camera time to process everything between one cycle and the next one, and since your conveyor will also be slow, it might give you time to process everything. If your blob detection camera, maybe it's processing things too slowly. Alright, so let's get to the script again, and you can not only change the image analysis frequency over here, you can also multiply it by a scalar number in here, all right? So if you wanted to change it in here, for example, do the same thing, you could also multiply it by 10 in here, and it would have the same effect as when you change it in here. All right, so the next thing that I wanted to talk about is this element in here. So you always should do first the sim handle vision sensor, because this is what actually initializes and this is the element that's setting up your actual camera. And this sim get vision sensor image is what it's giving us the image that the camera is seeing. All right, so if I give the sim get vision sensor image the camera parameter like it is, this will give me an RGB picture. All right, so instead of giving me so this, what we do is first it would give me all of the red values, then it would give me all of the green values, and then it would give me all of the blue values. Since this has 3 times the size and we want to save as much processing time as possible, what we're doing is, and this is already in your scripts, we're going to add this parameter in here, and what it's doing is asking that when we get the vision sensor image, we get it in grayscale instead of RGB. All right, so what we're doing here is, like, every time the image analysis frequency is up and it's time to pick up an image again, we'll pick up a new image in here. All right, so the code, I'm giving you 2 sample codes in here. This is just going over the image. So what this is doing is that it's checking that, this is the comment. So what is this doing is checking if I have an image, then this would go over the number of columns, and this would this would go over the number of rows, and this would go over the number of columns. Since they're the same, it doesn't matter. I could use res1 in here too, because it's just it's a square image. So what this is doing is it's going over the image as if it were a matrix. So this is going by I rows by J columns, and this is just getting the pixel. So this is just an example of how you should get the pixel. So to the function get pixel, what you do is that you give it the image that you just got from the sim vision sensor image. you give it your position I, your position j, and then you give it the maximum amount of columns. So it could be res 1 or res 2 because in this case they're the same. And if I wanted, for example, to, instead of getting this pixel, if I wanted to change the value of the pixel, so I'm going to give you an example. If I wanted to do thresholding, for example, and I wanted to check if the pixel value is greater than 130, I want to make the pixel completely white, and if the pixel value is less than 230, I want to make the pixel completely black. So I would just make my image completely black and white, which is thresholding. So the thing that I will have to do is check first. So I would do if, and I'm going to get the pixel. So I'm just going to copy this. So if the pixel that I'm getting is greater than 130, then let's set this pixel value to 255, which is completely white. So what I would have to do is I would do set pixel, and then after giving it the image, my x and y, or number of rows and number of columns, and the max number and the size of the amount of columns that I have, what I would do is I would add the value that I wanted to give it. So I want to make it completely white, and else if the pixel is less than 130, that's what the else would take me to, I want to set this pixel value to completely black. So I would make it 0, and then I would end it. So this is an example of how to do thresholding. So the last thing that I wanted to address is what happens if I want to copy the value, if I want to copy this image in another variable. What you would usually do is, if I want what I have in this variable in a second variable, because I want to maybe apply 2 different filters to the images, to my image, and I don't want my image to get affected by the first filter before I apply my second filter. So imagine that we want to apply 2 different filters to the image to do 2 different things. So we need 2 copies of the image. So what you would usually do intuitively is just you would make image 2 and assign it to the image. The problem is that if you do this with numbers of strings, it's fine. But if you do it with tables or VREP arrays, Lua arrays, what it happens is that even though it looks like these are 2 different variables, since this, what this really does on the back is that it's not that it's copying the value of image and pasting it in a new variable. What this is really doing is that this array is saved in some place in the memory, and this variable is kind of has a pointer to this array so you can access it. So when I assigned image to image 2, what I'm doing is that image 2 will also point to the same place in the memory as image 1. So the effect that this would have is that if I modify a pixel value in image 2, I would also get this modification in image. And the same thing would happen the other way around. If I modify somehow image, the change would also be reflected in image 2. So what happens if I want 2 different copies of the same image? And this is where the copy function that we made for you here enters. So this is actually making a real copy of your image, so you can manipulate if you want to have a copy of your image, you can, and the modifications, if you modify image copy, it wouldn't be reflected on image. So if you're gonna copy an image, don't just do this. Don't assign one image directly to another variable. Copy it first. So use our function, do copy, and this will let you have a copy of the image, an actual copy, and they won't bother each other in any way. So I'm going to post this, even though it only has a small change, so you guys can have it. And this will be all for the tutorial.